They come out of nowhere, boom, zero visibility. And that's terrifying.
Weather systems have a huge impact on air pollution.
You see these big clouds of pollen over top of cities. It looks gruesome. Air pollution is invisible most of the time. What's out of sight is out of mind.
I want to make sure my daughters don't have to deal with this invisible killer.
We've always had extreme weather. But over the last 20 years, as climate change has accelerated, it has mutated and become more dangerous and unpredictable. From dry lightning, to the polar vortex, to bomb cyclones, and the fire tornado. Welcome to the new reality. Welcome to mutant weather. Humankind is watching our planet warm at accelerating, alarming rates. A hotter Earth and shifting weather patterns are worsening air quality, fueling dust storms, and suffocating our major cities.
Climate change is all about change in the atmosphere. It's weather systems shifting from one place to another, whether it's wetter or drier, hotter or cooler. That's going to affect the level of air pollution in the air. Climate change will have potentially dramatic effects on different parts of the world for air quality.
From the southwestern United States to India and China, the world could soon be facing an air apocalypse.
When people think about climate change, they primarily think about change in temperature and warming. But the other thing that we tend not to think about so much, which is also extremely important, are the changes in air quality that we have produced over the last few decades.
For over a century, our industrialized economies have been burning fossil fuels and belching pollution from smokestacks and tailpipes. This includes greenhouse gases that trap heat, warming global temperatures.
It's been increasing a lot faster in the last few decades because we use a lot more fossil fuels than we used to. And those gases, of course, are retaining energy and allowing the world to slowly but surely warm.
As warming increases, so too does air pollution.
Air pollution is too much the wrong stuff in the air at the wrong place in the wrong time.
We have, along with the emission of carbon dioxide and the emissions of methane introduced into the atmosphere, unprecedented levels of lead, sulfur, cadmium, small particulates in the atmosphere, on and on and on. A lot of nasty things that dramatically impact our health. Close to 10 million people a year die from bad air quality.
We have huge numbers of premature deaths coming from areas that are affected by severe air pollution.
We're in the age of mutant air, with deadly smog, suffocating pollution, and epic dust storms threatening our lives. July 9th, 2018. It's a dry and dusty summer in Mike Olbinski's hometown.
Based out of Phoenix, Arizona, I chase storms for a living.
Phoenix averages the second lowest amount of rain of any U.S. city, just 8 inches per year, creating the right conditions for mutant storms called haboobs.
The haboob is basically a dust storm, a wall of dust. And it has its origins from the Middle East. It's an Arabic word, much like the word monsoon, which we also use out here.
In Arizona, some of North America's largest haboobs form, usually during monsoon season between June and September, when the state gets up to half its annual precipitation from frequent thunderstorms. And this July, monsoon season is expected to be true to form.
July 9th, 2018 was one of my favorite haboob chases of all time.
The elements are aligning for a mega haboob, potentially one of historic scale.
To form a haboob in Arizona, we look for conditions where it's very hot, but it's also very dry. Now, it has to be unstable enough to form a thunderstorm, because it's that thunderstorm that creates the winds that picks up all that dust off the desert floor.
There's thunderstorms that you'll get hit by a blowing wind, and you also know, like, whoa, it got really cold, and this gust of wind hit, and the trees start blowing, and then maybe a storm comes behind it. But there was no dust with it because you live in a place that's just got trees and grass and all that. So out here, these dust storms form from thunderstorms, creating this big outflow boundary of wind that starts pushing up, and as it starts picking up dust, you start to see that more and more. And so really the dust is just getting picked up by this wall of fast-moving wind.
Haboobs really are the gusty edge of big thunderstorms, and so they're fed by the size of the thunderstorm itself. The biggest haboobs are associated with large thunderstorms. Sometimes we call them supercell thunderstorms because they're big complexes of storms that are the entire depth of the atmosphere, and those huge storms drive out very cold winds at the bottom of them.
There are different types of thunderstorms: a single-cell thunderstorm, a multi-cell thunderstorm, and then the big gun, the supercellular thunderstorm, which is a whole other ball of wax. So that's where we're talking about something really different, and that's rotation in a thunderstorm. A supercell is one that actually starts to rotate, and that has to happen due to wind shear. So when we have winds coming from different directions with height, we can get the entire thunderstorm to start to spin.
And when a thunderstorm starts to spin, it can sustain itself for hours and produce a powerful downdraft that creates a haboob.
When the rain-cooled air falls from a thunderstorm, it increases its speed. And like pouring a glass of water on a table, it spreads out in all different directions, picks everything up that's on that table. So that downburst is doing the same thing with the desert. It's rushing to hit the desert floor, and then it picks up all that dust, and it spreads it out in all different directions.
A downburst is when you've got such cold air coming in from the upper levels of the atmosphere to the surface. And when that happens, we can get this cold pool sort of out ahead of the thunderstorm, and it often will form a shelf cloud, which are really remarkable to see, and they look like these, almost looks like the end of the world or a big spaceship coming your way. But what that is the cold air is pooling out of the thunderstorm, and that can create very strong winds. And these strong winds are coming directly out of the thunderstorm, and it can accelerate as it gets to the surface.
So if you can grow a big thunderstorm and it happens to pass over a very dusty surface, such as a dry riverbed or abandoned farmland, then it will kick up a lot of dust, and it can transport those over neighboring areas, whether that's another farm or whether that's a large city.
Anticipating a monster of a storm, Mike checks its progress.
Waking up on July 9th, looking at the models again, they held consistent for 3 days straight. A very strong line of storms moving off northeast of Phoenix, where these cliffs and storms love to form on there, and the models just had a big, heavy line moving right through town. And I knew if they move through Phoenix and keep going southwest, they're gonna pick up dust, because that's where it happens. Not only are they gonna be good, they're probably gonna cause damage. So there was like a little bit of, nervous excitement for that day.
But this storm is unlike anything that Mike had chased before. Ottawa, Canada. Don Jurgens and Daniel Coates track airborne pollen, and they're seeing some surprising things.
Pollen bursts or pollen storms. Pollen vortex is also something I've heard. We see a much higher than normal pollen level in the air at certain times of the year.
It's a large amount of pollen being released all at once, and you've seen things happen in Carolinas, in Australia, and in South Africa recently, where you see these big clouds of pollen over top of the skies or over top of cities, and it looks gruesome.
Doppler radar can even pick up these pollen grains as they're moving across the landscape.
Changing weather can make pollen events much, much worse.
If air masses aren't moving and you have the same air mass over you for day after day after day, and the pollen season is underway, it can really produce heavy amounts of pollen. So we can start to see the pollen levels go from low to medium to high to very high, and that can really affect people that have allergy issues.
Climate change is creating more days with stagnant air masses that keep pollen trapped at ground level.
Pollen is a huge issue. It is something that affects millions of people worldwide.
Pollen affects up to 25 to 30% of the population in any given country, and so it has a huge impact on both the economy and people's health.
Here's what happens when pollen invades the human body.
Pollen creates an overreaction in your immune system. Your immune system sees something coming into it that's foreign, and that's why you see people who get sick.
You might get watery eyes or a runny nose, coughing, even asthma can kick in. And folks who have asthma problems really have to be careful.
It is a severe issue for human health and human quality of life, and the fact that we just accept it as an everyday issue baffles my mind, because people suffer dramatically. Some of them, it's almost debilitating how much they suffer from seasonal allergies.
Mutant weather is forcing us to invent new terms to describe alarming phenomena. Terms like dry lightning, the polar vortex, and the firenado. But the first of these new terms, smog, was popularized some 70 years ago in London, England.
It was brutal. The smog in London was nasty. It was a result of burning a lot of coal without a lot of restrictions on the smokestacks. So it's just all that smoke was going into the lower lying air, which was combined with actual fog. In the 1950s in London, and they had a lot of smoke and fog at the same time, and they contracted the two words together to say smog.
The name smog sticks and quickly spreads around the world.
Since then, though, we've really expanded it to consider modern smog, which would be photochemical smog, the kind of thing you get over a large city like Los Angeles, for example.
Smog doesn't come in one shape or form. It comes in a variety of ways. That's what's so insidious about it. Low-level ozone, for instance, add into that particulate matter, mix all that together, shine sunlight on it, and now you have this horrific mix of chemicals that sits at a low level, sits right on top of your city.
These days, photochemical smog, or just smog, is really a product of car exhaust and vehicle exhaust, and sometimes some smokestack exhaust, and other nasty air pollutants reacting in sunlight. Together, this big soup they form is called smog.
And there are alarming signs that global warming and changing weather are making modern smog much worse.
Smog can be really adversely impacted by weather patterns. The more calm or still that the air is, the more stagnant it is, the more likely it is for any kind of emission, smoke, tailpipe, whatever it is, to stay right where it is and not be blown away. And the more it can build up in a confined space, the worse and worse it gets, the higher the concentrations will be.
Under normal conditions, the sun heats the earth, warming the air closest to the ground. As you move higher in the atmosphere, the air is cooler. The warmer low-lying air rises, and as it rises, cools again, so the air continues to circulate. But sometimes, low-lying air will cool faster than the air above it, which traps it under a warm layer. Cool air below, warm air above. This is an inversion. And as industry puts pollution into the air, it remains trapped close to the ground, with nowhere to go, until strong enough atmospheric activity can shake things up and move the pollution away.
There's an interesting relationship between smog and storms. When you have an inversion, smog gets trapped in that lower atmosphere right over top of the city that you're living in, and storms tend to break that up. They tend to actually overturn the atmosphere and clear out the smog. So your best days in terms of air pollution are just after the storms or during them.
Some scientists predict global warming will worsen existing air pollution in many places around the world. Heat waves and increasing periods of stagnant air will cause smog to linger in place, triggering asthma and other dangerous respiratory illnesses. Phoenix, Arizona. Storm chaser Mike Olbinski is watching as a monster haboob forms. But Mike's got a problem. He's not even in the same state.
The morning of the storm, I was out in California. I knew the dust storm wasn't going to happen until later in the afternoon. I had planned to drive all the way back to Phoenix, get home, grab food in the cooler and all the camera gear, and then head south. And there's going to be a big line of storms going through Phoenix and Casa Grande, and they're going to push west down Interstate 8, and then we'll just jump in front of them and we'll have a dust storm. I raced here, and amazingly, we were just about 10 minutes behind our schedule.
The haboob is not waiting for Mike to catch up.
I saw some microbursts just kicking up dust. We're like, okay, here it goes. I got on the freeway trying to blast west, and there's a wall of dust in front of us already. So we were on the wrong side of it, and so I knew we just had to get through of it. Incredible. I go from crazy pouring rain to driving through just zero visibility dust.
Mike is a veteran storm chaser, and he respects the power of this haboob.
Haboobs, once they hit you or they come out of nowhere, boom, zero visibility. And that's where it's terrifying. That's where bad accidents happen. Right around, this area where we are, there's been multiple, multi-car crashes, fatalities.
Oh boy. Dust storms in Arizona are particularly deadly on the interstates. There's a stretch of interstate between Phoenix and Tucson that's one of the most deadly in the state only because of dust storms. Your visibility can drop from unlimited to only a few meters in a very short time, and that creates huge problems for people driving down that road.
But haboobs bring another danger. These towering clouds of dust carry serious health risks.
Some people absolutely love them for the photographic nature of them. Other people take them a lot more seriously, knowing how dangerous they can be. We urge most people to go indoors because a haboob is actually, in this part of the country, a health hazard. It carries spores and fungus that, if you inhale, potentially can make you very sick.
Haboobs here in the Southwest contain a mixture of very coarse sand, which makes them look spectacular, but they also have much finer particles in them, or they can have other chemicals in them. For example, if that dust originates over old farm fields that has fertilizer, then those chemicals be carried in the dust as well. Dust pollution is quite literally air quality problems that come from too much dust. Dust exposure can affect our health mostly through our lungs. When you breathe in dust into your lungs, the natural thing is for that dust to be trapped on the mucus inside your lungs, and you might cough or expel it in some way, or your body itself has cellular mechanisms that will help get rid of it through your body. But sometimes it can be overwhelmed, or it might not be able to do that.
A warming world will cause deserts to expand and create far more dry, dusty landscapes that can taint the air we rely on.
When we inhale dust, the effects can be immediate. We can be caught in a dust storm and be coughing and hacking right away, or they might be far more subtle effects that take years or even decades before we notice the health effects.
July 9th, 2018. Driving outside of Phoenix, Mike is white-knuckling his way through the storm.
After I punched that wall of dust, there's not very many stops on that interstate, but there's an overpass that I love, and it's Vehicle Valley Road. We're up about 30 feet, so you can see the mountains, you can see the desert floor. When I'm out chasing and I'm on something good, I literally cannot stop the car fast enough. I'm sometimes getting out of the car almost before I throw it in park, and I will throw my door open and race around to the back, and sometimes I have my cameras on the tripods already. Anything I can do to shorten the amount of time from stopping to setting up my camera, I do. And then I turn around and look at it.
Oh my God.
If you pull over, and it just basically came right at me.
Wow. Wow, 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 wow.
Mike is now face-to-face with a colossal haboob as its surrounding storm generates 45,000 lightning flashes.
In person, a haboob can be kind of terrifying. A mile tall, touching the base of the clouds with massive clouds building over them, 100 miles wide, and dense and churning, and they can be freaky to kind of see coming at you, especially, if you haven't experienced them before.
The big wall of dust associated, that haboob, is really due to the thunderstorm winds collapsing, and it pushes out across the entire desert floor, picks up all that dust, and it looks like a big wall of dust. It might be moving at you 20, 25 meters per second. And so it might look like it's not coming at you, but it's really progressing.
Monster epic haboob right here. This thing is unbelievable.
It started becoming spookier with big old thunderheads building over it. The wall of dust, sometimes they come and they're just a wall of dust with some clouds over it, but if you have a big towering thunderstorm above it, they look so scary.
Ottawa, Canada. Don Jurgens and Daniel Coates have been analyzing a vexing increase in pollen pollution. No easy thing to do, given the nature of pollen.
It's too small to be able to see with the naked eye, with the exception of the yellow ring that you get around puddles after it rains.
It's not like air. You can see it, but pollen is pretty much invisible to the naked eye. So people inhale it and they have no idea they're actually inhaling the pollen.
To track increases in pollen, Don and Daniel developed a way to make the invisible visible.
The samplers themselves are located at usually 5 to 6 feet in height, and so it's representative of the air that we breathe. It rotates at 4,500 RPM, and it spins for 1 minute and it's off for 9, and it does this for 24 hours.
Everything that's in the air slams basically right against the rods that is coated in a silicone grease, and that captures all the pollen, spores, and anything else that's in the air. And once those rods are removed and then shipped to our office, we have a beautiful depiction of what's in the air through the pollen analysis that our technicians do.
Once we receive the samples here at the laboratory, stain is added and then it's viewed under the microscope. And then one of our technicians will view the sample and do the analysis for both pollen and mold spores that is in the sample.
After the analysis is done, we take the counts and we create forecasts for things like the Weather Network or apps, and people can see up to 4 days ahead what's going to be happening in the air.
And when they crunch the numbers, what do Dawn and Daniel find?
We have over 25 years of data for most of the sites across Canada, and what we're seeing is a large increase in pollen year over year in some of the major metropolitan cities across Canada. See, allergy is just getting worse and worse every year.
It's a trend that worries weather watchers outside of Canada as well.
And if we continue to increase the pollen, we may start to see folks who haven't been allergic to pollens in the past now become allergic because there's just so much of it in the atmosphere.
Phoenix, Arizona. It's 5 p.m. and time is running out for Mike Olbinski to chase his storm of a lifetime. Haboobs are powerful, but also short-lived.
Early on in the day, it felt like it. The models were very consistent, and as we were out chasing, the storms exploded just like they were predicted.
But once they hit the ground, giant dust storms are also unpredictable.
The monsoon is pretty tough to forecast. There's different spots of the state where it's just going to be drier and there's less vegetation, and that dust is just going to feed into it and make it even better looking. And if a wall of dust starts traveling over an area where there's more vegetation or a city, it starts losing its intensity. So for me, I'm always thinking, where is this thing about to get good? Haboob was kind of moving to the southwest. We're gonna go west, stop again, and then we'll see it. Got to Gila Bend, pulled over to a wide area that I know, and waited, and waited, and waited, and the dust never came over the mountains. I'm like, did this day just end? I was so excited about 20 minutes ago, and now I see nothing. And that dust storm had just careened off to our right to no man's land, and there was nothing else. And I thought the day was done for a second. And then I was looking at radar and noticed the storms coming through Phoenix were so strong, and they were pushing down right towards us. That's gonna come through and create the dust storm that we've been waiting for.
Radar is the biggest tool that we use when we're storm chasing in the field. Basically, radar is sending out a signal to the storm, bouncing back to the radar, and collecting data. And we use that to see, how heavy the rain is. We can detect snow. We can detect hail.
So went west a little bit more, pulled off in front of a farm, and sure enough, start seeing dust in the distance start coming again. And I'm like, here we go. It may not be great, but at least we're gonna get some dust. And it comes through this farm and picks up, and it hits us, jump back in the car, go west again, probably like 10 miles, jump out, and all of a sudden look back, and all of a sudden this wall of dust has just changed into something even more incredible than the first stop. Dust is the food coloring of the air, and you get to see the dust churning and swirling and what the wind is actually doing. And at one point I had, a tight frame on it, and I'm looking at it through my camera, and it's just this wall just slowly marching across, and there's mountains there, and the mountains are just dwarfed by this massive wall and the clouds above it. It looked like it was just this ominous wall just slowly marching across the desert.
When a mutant haboob is on the move, most people cower and run for cover. But storm chasers like Mike see things differently. And then the chase is on again.
And then jump in the car again right before it hit us, kept going again. We stop again, and it's even better. It was so incredible. I just had to stop right there on the freeway and turn around because I did not want to miss what I was looking at. And I stop and I just look up, and it's just a mile high. And stretching across from me, you can see just the folds, the density of it. Some of them can look like, you know, an orange kind of like washed out wall of dust. This looked like a living organism, and it's the density and the churning and stuff was unbelievable. And I'm running around just trying to take pictures of this and that and whatever I could to capture it.
Climate change is influencing weather systems by triggering a chain of events that has surprising and dangerous consequences for air quality.
Exactly how climate change is going to have an effect on air quality in the future is one of these questions that we're doing a tremendous amount of research on. I've talked to a lot of atmospheric scientists. One of the aspects that they've seen with their research is this clustering of events. Rather than having storm systems moving across the planet at a regular pace, at a regular time, what we're seeing instead is these storm systems are stopping.
This is new behavior for storm systems.
What we're seeing is 30 storms a month. But rather than occurring one per day, they're occurring 10 in one day, and then nothing for a long period of time, and then 10 in another day. And you wouldn't think that that's associated with air pollution, and yet, when you only have these storm systems occurring in clusters, what you have is stagnant air masses sitting in one place for a long period of time.
And that's a huge air pollution problem.
Stagnant air masses just sit over an area, the air doesn't move, all that pollution that we're producing just doesn't get swept away, and we're breathing that stuff in and living in a soup of our own making. Think of it like 1,000 cars all sitting there idling, dumping carbon dioxide, ozone, carbon monoxide, but it can't get swept away, it can't get cleared away. Now you're wandering around breathing that junk in. So stagnant air masses are pollution's best friend, but humankind's worst enemy.
It's nearly sunset, 200 miles southwest of Phoenix, Arizona. It's been a long day of storm chasing in 105-degree Fahrenheit heat for Mike Olbinski.
We chased stop after stop all the way to Yuma until dark. The density and the structure of all of it, and it just kept going. And we got it at this place where it just lit up orange at sunset, and it was just churning down the freeway. And I've never had a chase of a dust storm that was just so thrilling, so photogenic, with the most perfect network of roads.
A mutant haboob is thrilling to a storm chaser, but its surrounding storm snaps trees, drops hail, and creates life-threatening conditions across the Southwest. Flights are canceled and streets are flooded in Phoenix.
This haboob must have traveled over 150 miles. There was just a lot of moisture. Got the heat. You have something else, something juicier in the atmosphere to help enhance these storms, push this thing and make it better.
Thunderstorms move as quick as the upper level winds want to push them. So they can go really slow. They can be moving at a snail's pace, like 5 miles per hour, 10 miles per hour. But then they could be racing across the Central Plains as much as, 80 miles per hour, over 100 kilometers an hour.
Upper-level wind speeds and the storms they push across the globe are dictated by the rotation of the Earth and the differences in atmospheric pressure caused by the way heat is distributed across the planet.
The largest haboobs that we see in Arizona, you can get the dust lifted up several kilometers off the ground. But then the winds at that level, transport the dust horizontally, and you might go 500 or 600 kilometers downstream with that lofted dust. So dust that started in Phoenix may eventually end up in Las Vegas or Los Angeles.
These storms were able to move along, hold together, and create this amazingly strong outflow with such intense wind, too.
Mike is not going to let anything stop him from capturing stunning images of the storm's last minutes.
When I stopped in Yuma to wait it out, it sandblasted my truck. The next day, I looked at my windshield, and I had tiny little, almost microscopic dings over the whole thing where basically it got sandblasted. Watching this just unfold and watching it happen exactly as you predicted and being in the right spot, having, you know, already predicted 2 days ago that I'd probably be here, these, you know, monumental days are the reason I chase.
Haboob's very awe-inspiring, very picturesque in some way. But then once you get in the actual blowing dust, it's not so spectacular anymore.
People will tell me later, like, I would have been running from that. That dust storm was coming to me. I would be hiding in my car, hiding in my house. Even if I didn't have a camera, I would stand there in awe and, you know, let the dust storm hit me, because I can't think of anything more exciting than watching these monstrous things of nature, you know, unfold before your eyes.
Burning fossil fuels puts pollution in the air and heats up our atmosphere. That extra heat worsens pollution by shifting weather patterns which create the right conditions for poor air quality, choking citizens from Cameroon to India to China. Officials are closing down factories and schools, as well as restricting driving during periods of severe air pollution. Changing patterns of wind, air, and temperature are creating the conditions for a new type of mutant weather, the air-pocalypse.
The Chinese air-pocalypse refers to the issue of significant air pollution. There's a couple of reasons that you're dealing with such a horrific problem in China, and one is the manufacturing issue, but the other half of it is that they are dealing with dirty energy sources. They've got lots of coal. They're trying to catch up to the Western nations, developed nations, by using whatever energy source they've got, and one of the easiest and cheapest ones is coal.
At the same time, in their winter, with very calm, stable conditions, so that the pollution builds up near the ground in higher and higher concentrations, to the point where you literally can't see between buildings anymore.
All the things that we enjoy, like smartphones, cars, forks and knives, all that manufacturing is now done in China. So we've taken all that pollution that we used to produce and moved it from our neighborhood to somebody else's.
The main difference between the London smogs of the 1950s were that those smogs were made of smoke and fog, whereas the air-pocalypse smogs in China are made without fog generally. It's really just stagnant conditions in winter with lots of buildup and a lot of pollution from huge, fast-growing cities.
Climate change has warmed the Arctic Ocean and Siberia, reducing the difference between the warmest areas of China and the coldest, causing stagnant winter periods where air masses remain in place for days.
In the Chinese example, very similar, still a lot of coal burning and other fossil fuel burning. And the sheer quantities there in the low-lying air in winter are making for really bad visibility as well as really bad particulate matter concentrations.
It's the concentrations of superfine particles that have researchers worried, especially what they call PM 2.5 particles.
PM 2.5 particles refer to particles in the atmosphere, really dust and very tiny particles of soot that are 2.5 microns or less, so very small, almost invisible. They're microscopic, and they can lodge very deep inside your lungs because they're so small. They get way down into the small alveoli, and if they stick there long enough and are not expelled by your body, then they can cause health problems.
Tiny PM 2.5 particles contribute to an estimated 4.2 million premature deaths globally every year. In China, the situation looks especially dire when combined with the effects of climate change. Scientists are finding that more frequent periods of stagnant air caused by a warming atmosphere will worsen China's smog and associated health problems. Add to that more frequent and long-lasting heat waves, and China is facing increasingly terrible health outcomes. This in a country that already loses an estimated 1 million citizens to pollution-related deaths each year. Ottawa, Canada. Pollen experts are watching levels increase year by year. They also know that global warming is increasing, and they wonder about the connection.
There has been research fairly recently in the scientific community that has explored the idea that higher CO2 levels can produce more pollen in different plants. Looking at ragweed, they found that higher CO2 levels were causing a higher level of pollen being produced by single plants.
CO2 is actually plant food. Plant food makes bigger plants. Bigger plants means more pollen. There's a lot of research out there that's actually showing the pollen levels are increasing over the past decade. That's increasing not only because of the CO2, but also because the growing season is longer.
With climate change, what you generally see is warmer weather. With warmer weather, you can see a lot longer growing season. This especially is true for the trees that we've seen over the last 25 years. So when you have the warmer weather, there's more ability to create more pollen in both the trees and the weeds and the grasses, and hence you have more pollen release in the air.
An increase in pollen in the air could lead to an increase in pollen-related mutant weather events.
As the pollen seasons get longer and there's more pollen in the air, you will see these pollen vortexes or pollen bursts happen on a more regular basis. You could see more and more of this happening in the future.
Phoenix, Arizona. Mike Olbinski understands that the beauty of dust storms is deceptive. As climate change dries out Arizona and other parts of the world, these storms are at risk of becoming more frequent and more destructive.
Climate change is changing things on a global scale. The climate is warming, the glaciers are melting, and I kind of almost hope that a lot of the stuff we're scared about doesn't happen, but I feel like it's probably going to. And I do believe that because of climate change, maybe there's more drought out here in Arizona. And maybe 2018, the reason we had such an epic dust storm was because it was so dry that there was just dust everywhere. And then we had an insane storm pick it all up, and it was the most historic haboob we've ever seen. The fact that we are getting less rain and more, drought and heat, maybe we get less haboobs, but maybe they're stronger.
We do see changes in the number of haboobs or large dust storms with climate change, but it's not always as simple as it seems. For example, because the amount of dust that a storm will blow will depend on the supply of dust on the surface. If you have more rainy days, then you won't have as much. If you have drier conditions, but enough rain to wash rivers down that then subsequently dry out, then you might have more dust. So it's a complex combination of conditions. Generally speaking, areas that weren't arid that become arid are going to have more dust storms. I'm an optimist about the future quality of the air because I think at some point in the next decades here, we're going to get to the point where there really is a shift away from fossil fuels to renewables. And that will really help not only climate change, but it'll also help air quality because the source for both of them is burning of fossil fuels.
Global warming is here to stay for the foreseeable future. The last 5 years are the 5 hottest years ever recorded.
Climate change is happening, it will happen, we will see dramatic changes in the next few decades.
Global warming makes air quality worse in a couple of ways. It makes us produce more air pollution because we're trying to either heat our homes more or cool them down more. And it also can make the air quality that we have worse by making weather conditions worse for the air quality, make them more stagnant in some places, or hotter to produce more smog. So actually 2 ways we lose with air pollution under climate change.
The real danger with air pollution is that it's a slow-moving, invisible killer. And it doesn't get you right away. It takes a long time to accumulate that damage, but eventually it's going to rear its ugly head. I'm definitely concerned when it comes to air pollution for my family.
And our problems with air are global.
emissions and smog and smoke can travel great distances across oceans. It can sometimes take days or weeks for it to do that. But if, in fact, we can measure on the west coast of the United States, we can measure the odd air mass arriving that has all the signatures of Asian air in it. And of course, there's air from North America that makes it over to Europe.
When pollution is blown away, it just goes downstream, which would be fine if Earth was an infinite plane, because it would just keep moving. But Earth is a globe, so when you move that pollution downstream, all that you're doing is moving it to somebody else, or eventually back to yourself.
Climate change will enlarge deserts in the southwestern U.S., northern Africa, the Middle East, and Australia, creating more places where haboobs could blast people with sand and dust. Asthma kills more than 350,000 people worldwide each year. A warmer world will create a longer growing season for pollen-producing plants, risking thousands more deaths each year. And as we continue to burn fossil fuels, pumping more harmful pollutants into the air that sustains us, climate change leads to more stagnant summer days. The more than 4 million premature deaths we currently see each year from air pollution could continue to rise. Eventually, we will all have to reckon with global warming and its effect on air pollution.
When we talk about climate change and air quality and health, it's easy to notice things that are easy to put in TV news, like hurricanes or major dust storms and haboobs. But in fact, the more dangerous thing might be the invisible part, the air pollution.
We should care about the quality of our air simply because we live in it. We exist in an ocean of air. It's what we need to survive.
The billions of tons of chemicals we add to the atmosphere each year have mutated the air we rely on for our survival. And, like the frogs slowly being boiled alive, we continue to breathe the air we've polluted, ignoring the invisible threat to our lives.